Lesson 1.3, Task 3. Identify significant digits. A significant digit is a digit in a measurement that carries a meaning in terms of the precision of the measurement. Right, so that's a definition. Make sure you have that in your notes. All right, also these rules would be helpful to know as well. So your rules for significant digits. All right, all non-zero digits are significant. All right, all non-zero digits are significant. So 4.316 has 4 significant digits. 295 has 3 significant digits. Those are very easy to indicate. All right, zeros between two other significant digits are significant. So 305 has 3 significant digits because the zero is between the 3 and the 5. It makes that zero significant. All right, this number has 6 significant digits. So you can see the 6 plus the 1, 2, 3, 4 zeros and the 8. So your 6 numbers here are your 6 significant digits. This 0 here is not considered significant. All right, zeros at the end of a number to the right of a decimal point are significant. 4.1000 has 5 significant digits. So these zeros are important because it's to the right of the number after the decimal. 0.9450, those are your 4 significant digits. Again, the 0 in front of the decimal, just like here, is not considered a significant digit. Zeros to the left of the first non-zero digit in a decimal number between -1 and 1 are not significant. All right, so right here we've got 0.00015. Only your 1 and your 5 are considered significant digits. For this one, 0.09108, the 9108 are your 4 significant digits. So the first 0, point, and the second 0 are not considered significant. And up here, all of these zeros are not considered significant. All right, zeros at the end of a number without a decimal point are assumed to be not significant. So 50,700 has 3 significant digits. So 507, the 2 zeros on the end are not considered significant. And here only the 94 are considered your significant digits. All right, so it says order the quantities by the number of significant digits. All right, so 2.15 has 3, this one has 2, this one has 1, 2, 3, 4, 5. These 2 would not be significant. This one has 1, and this one has 1, 2, 3, 4, and this one has 1, 2, 3, 4, 5, 6. Okay, so you can see that the zeros here on the right of the decimal makes a difference. If this did not have the decimal 1, then this would only have the 3 would be the only significant digit. So it says in order from least number of significant digits to most, the quantities are 0.0004, 0.16, 2.15, 300, this big number here, 2,200,300, and 4.30010. So it says choose the words to correctly complete the sentence. In the number 300, the digit 3 is significant. The digit 0 to the right of the decimal point is also significant. And therefore the number has 4 significant digits. All right, if there were no decimal place, then only the 3 would be significant. But when you have a decimal, even though it's a decimal 0, it makes that significant. All right, so it says select the significant digits. So this one's significant, this one, this one, this one, and this one. These two would not be considered significant because there's no decimal place. It's just beyond, it's just to the right of the 3. All right, so again, review your rules here. These are important to know, rules for significant digits. If you get to know those, then this will not be too difficult. That's all for task 3. If you have any questions, let me know. Lesson 1.3, task 4. Calculate with significant digits. The rule for calculations involves significant digits are given in the table. Rules for calculating involving significant digits. All right, so for the operations of multiplication or division, the rule is the result should be given with the same number of significant digits as the value with the fewest significant digits. All right, so if you multiply a 1-digit number and a 2-digit number, then the 1-digit number has the fewest significant digits, so your answer should therefore be in 1 digit. All right, addition or subtraction. The result should be given with the same precision as the least precise value in the calculation. All right, so if you have a number like 2 and you have a number like 2.3, 2 is less precise than 2.3. So your answer should be given with the least precise value. All right, so Lisa is measuring a poster that she wants to frame. She finds that the poster's width is 32 centimeters and its length is 45.6 centimeters. What length of frame and what area of glass are needed to frame the poster? All right, so 32 centimeters, this one has 2 significant digits. 45.6 has 3 significant digits. And 32 would be the least precise. This one's more precise because it's rounded to the 10th place. All right, so it says the calculation of the length of the frame is shown. Complete the sentence. The length of the frame equals 32 plus 45.6 plus 32 plus 45.6. So that's a total of 155.2 centimeters. Using the rules of significant digits, Lisa should round the result to. Okay, so remember adding and subtracting. The result should be given with the same precision as the least precise value. All right, since 32 is a whole number and this one is a decimal, we need to round this to a whole number. So 155.2 centimeters should be rounded to 155 centimeters to be using your rules of significant digits. All right, the calculation of the area of the glass is shown. Complete the sentence. Area of the glass is 32 times 45.6. That equals 1,459.2 centimeters squared. All right, now for multiplication or division, the result should be given with the same number of significant digits as the value with the least or the fewest significant digits. All right, so the number with the least or the fewest digits is 2. So we're going to have to give this answer with only 2 significant digits. Now remember, sometimes zeros are not significant. So how could we give the area of this glass? Well, we could round this up. So we can round that up to 1500. Now because 59 is greater than halfway to the next number, we can round that up. We want it to be close to this, but just using the rules of significant digits, we're going to have 1500. That means only the 1 and 5 are significant, which is the same number of significant digits as the 32. So it's a little tricky when you get to things like that, because you think, well, that's the exact area. That's the best answer. Right now, we're not exactly looking for the best answer for the area. We're just looking at how to apply the rules of significant digits. All right, so that is all for task 4. If you have any questions, let me know. Lesson 1.3, task 5. Calculate with significant digits. When a calculation involves multiple operations, round the result of the calculation so that it has the same number of significant digits as the values with the least number of significant digits. However, rounding should always occur at the end of a calculation to avoid round-off error. All right, so that's important to know. Always round at the end. All right, so here's a picture, and you can see time 1 is 3.3 seconds, and distance 1 is 33.7 meters. Time 2, 11.2 seconds, and distance 2 is 66.4 meters. So find the average speed. Average speed is the distance traveled divided by the time taken to travel that distance. Two methods of finding the average speed of the dog walker are shown below. All right, here's the preferred method. So your average speed is D2 minus D1 over T2 minus T1. If you notice, this is the same as the slope formula. You may have seen the slope formula last year in 8th grade. All right, so we're going to take D2 minus D1. This comes just from the numbers here. D2 minus D1 over T2 minus T1. So we're taking the numbers there and then simplifying. So they left all the numbers exactly the same. They divided it. Once they get this number here, then the average speed is 4.1 meters per second, and that's rounded to 2 significant digits. Since the smallest number here is 2, we need to round this to 2, but we're not going to do it until the last step. All right, the flawed method. All right, they change in distance, D2 minus D1, and then they round it 32.7 to 33. So they rounded after the first step before they did the last calculation. So because they did that, the average speed is 4.2 meters per second, rounded to 2 significant digits. So this is less accurate than the 4.1 because they rounded and then they rounded a second time in the answer. All right, so it says choose the words to correctly complete the sentence. The blank method rounded only at the end. The preferred method rounded only at the end, while the flawed method involved intermediate rounding in addition to rounding at the end. All right, and that's why it's called flawed, because it's not the best method. All right, choose the words and numbers that correctly complete the sentences. The value with the least number of significant digits is 3.3 with 2 significant digits, 1, 2. Rounding results to the proper number of significant digits should not occur until the end of the calculation. Therefore, the blank method produces a rounding error. So the flawed method produces an error. All right, that's all for task 5. If you have any questions, let me know.